Okay, so hello everybody, welcome to our next Brno Java user group meetup. Today we have Martin Kouba from now IBM, but Quarkus core engineer, one of probably like most core engineers that we have in Quarkus because you were there since the beginning basically. So today you are going to talk about MCP servers, which is actually an extension that you wrote yourself. So floor is yours.
Okay, thanks. Hello everyone. Welcome. Today we're going to talk about MCP. My name is Martin Kouba. As Martin said, I'm software engineer at IBM. I'm Quarkus contributor, and what is more important for today, I'm the maintainer of Quarkus MCP-server extension. Well, maintainer, developer, tester, architect, whatever. So what's the plan for today? So first of all, we should cover some basics of MCP. Just out of curiosity, does anyone here in the room know something about MCP, model context? Cool, perfect. Okay, and then obviously we should talk about Quarkus MCP server. We're not going to cover client. If you have any questions about client, Jan is here, so he might answer your question. So just a brief overview, history, goals, design, then we'll show the API and also some advanced features and developer joy, examples and so on. Before I start, here's a link to my GitHub repository that contains both the slides and the example. So if you want to, you can take a look and yeah, this one, those eyes with pink background, that's just an icon that basically means that whenever you see it on a slide, you can take a look at the example and you should find some code in there. So, part one, MCP. Most of you probably know what it is, but just to repeat, this is actually a quote from one of the blog posts from Entropy, and so that's basically a description from the creators of MCP, and they say that MCP is an open standard for connecting AI agents to external systems. They say standard, it's not, yeah, sorry. Speak out loud. So, they say it's an open standard. We talked about it later, but it's not a typical standard, as you might know. For example, RC or JCP and so on. But AI agent, what does it mean here? AI infused application is a synonym, and in the context of MCP, that's an MCP client, and it's basically an application that is using or leveraging a large language model behind, right? So it could be, for example, a chatbot. Typically, you have a client application that sends some prompts to the model and back. And external system here represents the MCP servers, and this is the part we are going to talk about. This is my interpretation of the first sentence. It's a standardization effort, right? It's not a standard per se, but it's a standardization effort, and the goal is integration of AI agents or AI-infused applications and external tools, prompts, and resources. So tools in the context of MCP means basically RPC. So remove procedure code. Prompts, these are basically prompt templates for users, and resources represent any data, binary, text, whatever. So I have a, well, it's not a very big picture, but I wanted to show you that this is how it looks in the wild. You have a large language model, and then you have two AI agents or AI-infused applications, and then we have MCP servers. And the message of this slide is basically that those servers do not communicate directly with the model, but instead they only communicate with those AI agents. There can be multiple AI agents or AI apps, AI-infused apps connected to one server, but there can be only one, whatever. This is much better picture. Can you see the? It's big enough. This is actually coming from another blog post from Entropy, and I like it a lot because it actually explains how MCP tools usually work. So in this case, we have the model on the left, client in the middle, that's the AI agent, AI-infused application, and MCP server on the right. What is important here is that MCP client, when you start a session, when you start a conversation, usually opens a context window. So that's when you start writing your prompt or whatever. And in this case, when MCP server is used, it usually connects to the server and asks for all the tools available, right? And the server returns a set of tool definitions, basically description, arguments you can use, and so on. But the important thing is that these definitions become part of the context window, right? They are appended to the context window that we are using. And then another important thing here is that if you look at the communication between those three blocks, you can see that it's up to the model to decide whether a tool is actually used or not, right? MCP client connects to the server. Server responds and the response contains the tools that are available, but it's up to the model to say, I want to use a tool A or B or C or whatever, right? So it's not the client that calls the tools, or it calls, but it's kind of a proxy. So this is important thing. Model is the one who decides whether a tool is actually used or not, whether your server is involved or called. Another important thing here is that if you look at this, the context window, you can see that not only the tool definitions, but also the results from the tool are included in the context window. What does it mean? Well, basically, if you provide an MCP server, they will have thousands of tools with long descriptions. All these things become part of the context window, and as we know, most of the models have a limit about the size, they define the size of the context window. And yeah.
So in terms of, for example, card code, then the card code is actually the MCP client or not?
Cloud code is the client, yeah. Or cloud, yeah. Or cloud the client and UI, that's the client.
Yeah.
So what I'm trying to say is that you should be careful when designing the tools, because all that you provide here becomes part of the system, of the context window. And given the fact that we have a limitation there, it might happen that you hit the limit very soon, right? Because if you, for example, if your tool loads one table from the database that contains thousands of records, all these records become part of the context window, because the model has to know all the results from the MCP service. Okay, so that's just an overview now. Back to the beginning. So model context protocol, it's quite ambiguous, the name, but it's an open protocol. It has MIT license. It's actually a specification that consists of specification document, that's large text, and JSON schema that basically defines how the messages that are sent from the client to the server look like, right? As you can see, the first version was released a year ago, so November 2024, and the last stable version, or how we call it, is from this summer. Of course, they are working on a new version now. Then we have some official SDKs. Basically, a lot of SDKs for most programming languages if you know, and they are used to build clients and servers. There is even SDK for Java, but we don't use it in quarkus-mcp-server, nor in Quarkus launching or launching project. We can talk about it later. But another thing that they provide, that is part of the MCP, is an application called MCP Inspector, which is basically a JavaScript application that can be used to test your MCP service. It's a web application. You run the application, and then you can connect to your server and test tools, resources, and so on. But it's like manual testing, obviously. Okay, and now missing pieces. From my point of view, obviously. So the first and very important fact, that's why I said that it's not like a typical standard, is that MCP is not backed by a foundation. It's driven by a company called Anthropic, which stands behind Claude, its models and tools for development and so on. So it's not a typical standard in a way like RFC, or if you are coming from the Java world, like the Eclipse Foundation or GCP and so on. It's driven by one company, which is quite problematic. I did the presentation in this summer, and at that time it was really the development review process was not clear at all. Things got improved this summer, but the problem is that it's still very specific to this specification. It's like they're not reusing existing standard processes like existing foundation, CNCF, and so on. And this one is very practical, or rather impractical, because if you come from the Java world, you can be used to the fact that there exists something called TCK, like Technology Compatibility Kit. Basically a set of tools that can be used to verify that your implementation is correct, right? So for example, if you have a specification in Java and there is a TCK, you run your implementation against this TCK, and if everything passes, then you can be like happy that you satisfied all the requirements and so on. This doesn't exist in MCP, right? So during the last year, thousands of servers were created, many clients, but nobody really knows. It's quite chaotic because there is no way how to verify that your server actually is compiled. But the good news is that it's one of the priority areas, at least they say, for the next releases. So hopefully, I don't know, in a few releases, maybe sooner, we'll have something like this. From my point of view, it's not very good or impractical because, I'm quite lazy, like most of the developers, and this means that I have to write my test suite completely. Because if you have TCK, then you can rely on, usually it's a set of tests, large set of tests that you can run, and then you can save your time. So in here we have to write our own test suite. Yeah?
What if some of the features are optional? Like,
Sorry?
I don't know, the transports or authentication.
Yeah, some of the features are optional, but that shouldn't be a problem. I mean, even the TCK can say this part is optional. If you support this transport or if you support this feature, then it's optional. Right now, it's really it really depends on each client. For example, I will show you a client that is called Goose. Goose is a CLI or UI application, like chat application that can be backed by many models. And MCP defines something called initialization, where the server and the client negotiate. Like the server says, I'm supporting these features, client says, okay, I'm supporting this one. And this is a typical example. I tried it just today. where our server responds, I'm supporting or I support tools, and Goose is asking for prompts. Well, there's a typical example that says the client does not behave like you would expect, because you say, I'm not supporting prompts, and he's asking for prompts. So it's, never mind. Okay, concepts. Client and server, they send messages back and forth. The messages are JSON, and it's actually JSON RPC.o messages. It's not important. This one is important. There is a notion of.
Before you move on, because I still don't get it, like, what is then actually the protocol if you can have miscommunication between the client and the server? If there is no like verification. So you are saying basically that if I write my AI-infused application that is client, basically, it can stop working because somebody updates the server and is no longer sending data back as I expect?
Can happen.
Okay.
Like you don't have a way to verify that the server is actually misbehaving or not. Anyway, back to the MCP concepts. There is notion of transport. It's quite important because that basically, okay, server and client, they send JSON messages, but the transport actually defines how exactly are the messages sent. So we'll talk about the default transport or standard transport later, but it basically means one typical transport is HTTP, in which case it means that we are using HTTP to send messages back and forth, right? Yeah, so the features I talked about it. This is another one, interesting. Client sends messages to the server, but can also provide some features to the server, right? It's called client features. Typically, it sounds exotic, but sampling basically means that the server can ask the client to send a prompt to the model and return the response back. Of course, there is a human in the loop, so that the server cannot just send any arbitrary prompts, but it's quite interesting. Now the problem is, if you look at, this is a list of some clients that we actually have. Sampling is here, and take a look, this means not supported. And if you look at the list of all the clients that are there, basically most of them don't support it. So that's fine, because sampling is actually optional feature. You can test it during negotiation. You can see whether the client supports it or not. But my point is that you have to be careful here again, because your server, which can be used for many clients, has to basically check whether sampling is supported or not, and then behave in some way. Okay, transports. Like I said, that's the way how the messages are actually sent, right? So MCP currently defines two standard transports. The first one is standard input-output, in which case basically the client starts a new subprocess with the server, and it's using the standard input-output for sending messages and reading messages. Right? Very simple. In this case, you only have one client connected to one server, right? Well, actually, the client can spawn multiple processes or subprocesses, but the server is always connected to one client. And the other standard transport is HTTP. The difference here is that obviously one or more clients connect to a running HTTP server. But as I said, it's not a traditional specification. So in the first version, they introduced HTTP, they called it HTTP SSC transport. It got introduced, and it was quite simple. In this transport, clients send HTTP posts to the server with messages, and there is one SSC channel open from the server to the client, and server sends all responses using this SSC channel. Right? It has some advantages and disadvantages, but never mind. In the second version of the spec, they said this is completely deprecated, don't use it. And we have something called streamable HTTP, very weird name. And this streamable HTTP tried to solve many problems here with the first one, but they introduced another. And one of them, or from my point of view as an implementer of this stuff, it's much more complex, sometimes really weird, and it doesn't solve the main problem they have probably, because now in the latest draft they're trying to maybe not deprecate this one, but modify it in a backward incompatible way, because they want to make MCP completely stateless, which is not the case right now. So it's really difficult to make it all work. Okay, enough of MCP. Now something about quarkus-mcp-server. So it's a Quarkus extension that lives in quarkus. Hopefully most of you know what quarkus is. Quarkus is basically a GitHub organization that provides some infrastructure for community extensions. So when you start writing quarkus extension, they provide you some configuration for GitHub Actions and so on. So that, for example, release is as simple as creating one branch, everything works out of the box and so on. Also, the documentation is published for you and stuff like that. If you have an idea about Quarkus extension, definitely go visit Quarkus. So, you released the first version in December last year, so it was 1 month after the first release of the spec. And yeah, the last version is 1.7.2. Quite a lot of versions released yesterday, right? What were the goals? So the first and fundamental goal was to provide declarative, which is very quarkus idiomatic, and programmatic API to implement the server features. And it should be independent of the selected transport. Because the whole idea with transports is that it's pluggable, so that you write the core API or whatever, and then you use HTTP, STBO, whatever. Obviously, that's a quarkus idiomatic, convenient, developer joy, whatever. So, design. Quarkus is built on top, or the programming model in Quarkus is built on top of CDI, so we use CDI as well. And in the Declarative API, you just annotate the business method of a CDI bean. That's all. We do everything for you, basically. For Programmatic API, again, we use CDI, we inject something that we call manager, and then you can use Blend API to add, remove, feature, and so on. Supported transports. We support both standard transports and both variants. That is the legacy one and the new one, except for one feature is called resumability and redelivery, and it's really weird, really defined. And we also support from the latest, 1.7.0 probably, WebSocket transport. The problem here with unofficial or non-standard transport is that client has to support the transport as well, right? So if you have a client that doesn't support WebSocket, you can't use it, unfortunately. But LangChain for J now supports WebSocket, right?
I have an open PR, but
yeah, almost.
not yet.
Okay, almost there. Okay, so let's see some code. This is the Declarative API in action. It's very simple. It's under the root it's been, even though we don't define a scope, because we add the scope automatically, we find any annotation that represents a MCP server feature. In this case, it's a tool. So we just have a class, and then we have a method and this is the important part. We define annotation, in this case it's MCP2, and in this case we only define description, which is actually very important in MCP. Because if you remember the first picture I showed you, this description is the hint for the model. So if you write a bad description or only description, then it will be never used, right? Because the model has to understand what your tool actually does. So this has to be, the other challenge here is that it doesn't, like I said, it becomes part of the context window, right? So it can't be like, I don't know, two pages of text or something like that. It has to be brief, but good enough so that the model knows how to use it. And then we have meta descriptor. That's important for us because, like in many other extensions, we use the meta descriptor to derive the execution model and stuff like that. So in this case, because we return string, which is like usual type, it's not non-blocking, we know that it will be just a usual blocking method. And here we have an argument of the tool. Again, we use a special annotation to specify the description. There are other attributes that you can use. So in this case, we are defining a tool that should answer the ultimate question to caps versus spaces, and the tool has one argument that says the programming language. So we expect the model to use this tool when we ask it to return an answer to question tabs versus spaces for a specific programming language, right? And body method is very complicated, just say this and that. Okay, let's show some code. Let's try it. So, this is the example, like I said, from the repository. It's a very simple Quarkus app. If you look at the POM, we have a few dependencies. We have hibernate directive because I wanted to show some database access. We have quarkus-mcp-server. SSE, that's the HTTP SSE transport we're going to use. We also have one extension for hibernate validator, and that's all. So, I was talking about the tool methods. Is it big enough? I hope so. So this is the method I was talking about, except that we have a few more things, but I'll talk about it later. So let's no problem. So let's start it in the dev mode. Okay, we start dev service because, as I said, I wanted to show some database access. So we have some import script and Postgres running in the background. And the first thing that you probably want to use is to see whether your tool actually exists or not. And for this, we have dev UI. How many of you ever saw this before? Yeah, most of you. So obviously, Quarkus joy, developer joy, we have to provide something in the dev UI. So we have something in the dev UI. It's a very simple UI that allows you to list all the tools, prompts, resources, and so on. You can see the names, descriptions, and so on. And you can also call.
Can you maybe zoom in a little?
Yeah. How about this?
Yeah.
Okay, so we have, this is the tool I was talking about, the answer. So I can try to call it, and let's use the Python. As I said, MCP is about sending JSON messages. So this is really low level. I'm sending this JSON. It's a blank Python, and the response will be also JSON. So it result is force content tabs are better for integration because I use Python here. So this is the very basic way of how you can verify whether your tool actually works or not. but it's not the only one. Now, I'll show you MCP inspector in action. You remember that was part of the schedule. So let's use it. It looks like this. Here you can choose the transport type and some connection information. So I'm going to connect to my server. I'm going to list my tools. It looks very similar, basically. It's for really simple testing. So here I have line Java, and I can immediately see response spaces are better for imitation, and I can also inspect the JSON that was sent there. It's like this. You scroll, the answer parameter or argument was Java, and that's all. And I can see the response. Right?
I think you mentioned that you use SSE as a dependency, so how come it works with string-level HTTP transport?
Yeah, that's a good question, because as I said, we first implemented SSE, and then we realized that the streamable is actually a variant of this SSE thingy. So we have one artifact that says both. So we call it SSE, but it actually implements the legacy one, the streamable, and maybe in the future we'll even implement the next one. So that's a good question. And yeah, so this works. And the last thing I wanted to show you here was actually using this with some real client. So I'm going to use Goose. Anyone here in the room ever tried Goose? No. Yeah. Okay. So I'm using Goose CLI because the UI actually doesn't work on Linux, and I'm using under the hood. I'm using Gemini. I'm sending requests to Google Gemini. Because I'm obviously not using any model locally. And I'm going to answer, so this is my question. Is it better to use tabs or spaces in Java? What should happen under the hood is that Goose will connect to my MCP server, and there's actually a visualization of this. Jack, that's the name of my MCP server, and it will call, well, not the model itself, but the client, Goose in this case, will call my server, and the response is coming back to my context window. So in this case, I was asking for Java, and again, spaces are better for indentation in Java, and I can also ask, and how about Python? And he called the tool again with the link Python, and the answer is the tabs are better for indentation in Python. So in this case, the model actually decided to use my tool because my description was super good. And we'll see later that we can actually observe the traffic on me and stuff like that. But that was just a simple example for now. So, execution model, like I said, those, we call them feature methods. Tools, prompts, resources, and so on. Like in any other Quarkus extensions, they can be blocking or non-blocking. Non-blocking means that you can use asynchronous types to return types of the methods. And you can use, we have an example that is using hibernate reactive. So we'll see an example in a few moments. And as I said, the execution model is actually first determined by the method signature, and you can use additional, these annotations are classical in the context of Quarkus. So we have a blocking and a non-blocking from small I. We have Quarkus specific run on virtual thread, so you can even use virtual threads here, or traditional transactional. In this case, we know that it has to be blocking no matter what. And like I said, we use the method signature to derive the execution model. So in this case, exactly the same class, exactly the same method, but if my method returns mutiny, it comes from mutiny, we automatically use the event loop to execute a method, right? This is how the programmatic API looks. Like I said, we inject something called manager. In this case, it's tool manager because everyone is using tools. And it's a little bit more verbose, but this is basically equivalent of the annotated method. The advantage of this is that you can at any time add your tool at runtime and remove the tool, right? The spec even even provides something like a notification from the server to the client that says my list of tools has changed, right? So whenever you, for example, do this, you add a new tool and you say register this for me, we send a notification to the client so that it can refresh the tools that it has. The other thing is it has to implement this correctly, but that's another thing. Okay, some advanced features, developer joy and stuff like that. It's just a subset because we have a lot of them and we don't have enough time for this. Traffic logging, that's very useful tool for development. It's transport agnostic, so that means that whichever transport you choose, you can enable this in the configuration, and you will see in the logs all those JSON messages sent from the server to the client. So if I stop use, restart my application, and open the I will open MCP Inspector again. So if you look at the console, nothing happened yet. But now if I hit connect, in the log of your application, you will see all the messages that were sent and received. So I was talking about the initialization phase.
Maybe zoom in again a little bit.
This one? Like this?
Thank you.
Okay, I was talking about the initialization phase where the client and the server negotiate some versions, supported features, and so on. This actually happened, and you can see that MCP Inspector is the name of the client, the version of the client, and they say we support sampling, we support routes, also protocol version and stuff like that. And the server then would reply, is it? Yeah, now this is our reply. We basically say, okay, hello, we support tools, we don't have anything else, we don't have prompts, resources, and so on, and we support logging, and this is our info about the server. Missing G. Jack MCP, the version of the application, and the protocol use, or the version of the protocol use. And the same applies when I start sending messages like list tools. I can again see that the server sent me a message tools list, please, and we replied something like, we have these tools. We didn't talk about these marvelous monsters, but we have the answer here. If you look at the result in JSON, it actually also contains information about the parameters, which is called, they call it input schema. So you can basically provide some information about the arguments of your tool. In this case, we are saying that we have an argument that is called, what is it called? Blank. Its type is string, description is the programming language, and the default value is Java, right? And this one we derive again from the method signature and stuff like that. So, dev UI I already showed. Yeah, I have this client logging is an interesting feature, and I have this for a reason. Client logging means that at any time when your tool, prompt, or resource is called, you can send log messages, they call it notifications, to the client. For example, I started doing something, blah blah blah. It's asynchronous. You just send message or notification to the client and continue processing with something, in this case tool. But as I talked about streamable HTTP, there is one problem with this with this guy, with this MCP log. Because streamable HTTP was designed to simplify use cases where you have one server sent to the server and one response is going back. Yeah? Typically, if we don't have this logging, you send a request and we respond something. But whenever you start doing something a little bit complicated, like in this case, we want to send actually 2 messages when this tool is executed, right? It gets complicated because streamable HTTP says that the client sends HTTP post to the server, but the server can actually open an SSE channel as a response and use this SSE channel to send multiple messages back. You see, it's very, this is very non-standard. And the other thing, imagine that you want to test this somehow. Imagine that you want to write an automated test for this. You can't simply send a request and expect a response using whatever, rest assured member or HTTP client from the JDK, because the server can actually open SSE and send multiple messages back. Very weird. Never mind. So this logging is for sending notifications back to the client. This is just a tiny nice features that we wanted to add, like adding default values. Like we mentioned, the default programming language was Java. In previous example, here we have something like age. The age of the programmer is, and we can specify some default value that is automatically converted. We can use optional so that it and use it like optional argument in your method. It's just very tiny but convenient. This one is really interesting, and I want to show you an example here. In this case, we want to leverage hibernate validator. Does everyone know here what a hibernate validator? Check out the validation. Yeah. So it's basically specification and standard, real standard. Originally coming from Java E, now Jakarta E, or Jakarta, yes. And it allows you to define annotations or declare annotations on your parameters. In this case, you see this add positive or 0, right? This annotation basically means that hibernate validator should validate your parameter or the actual argument that was passed to the method. And if it's negative, it should blow up. It's called constraint or constraint annotations. And if something goes wrong, you get an exception and so on. We integrated this into our MCP server so that you can use these annotations on the tool arguments. And we run hibernate validator for you and receive some error message, send some error message back. Let's see it in action. Okay, so this is it. Is it big enough? This method. It's a tool. In here we are using Hibernate Reactive because I wanted to show you the reactive stuff. So we return Uni instead of any blocking type. Uni comes from mutiny, and it basically means that we're using a reactive stream inside the method, and the method is executed on the event loop. But what's important here that we use with annotation, with transaction, which is a regular annotation to start not the JTA transaction, but either reactive transaction, and query the database. In this case, we have an entity that is called monster, like Dungeon and Dragon monster, and the tool, the description of the tool says we want to list the monsters, right? And then we have an argument here, which is not, where is it there? It's called minimal hit points, and it has this hibernate validator annotation. It's actually not hibernate validator, but the specification annotation. So it's constrained from declarative validation, and we say this value has to be positive or 0. If it's negative, blow up, right? And what we do is that we just use hibernate query language to select the monsters with hit points greater than the value. Does it make sense? Okay. So let's try it. First, let's use our dev UI again. So I'm going to back to tools. So minimal hit points is my argument. Oh, okay, 50 is maybe 60 maybe. So call, and it will return a JSON. If you look at the method, we actually return uni monster result, which is a record that contains the monster. Where is it? Yeah, here it is. Monster result that contains list of monsters, and under the hood we convert it to JSON, right? By default, you can change it, but by default we use JSON. So we returned a list of monsters where we have Phoenix, Giant, and so on. Okay, let's see what happens if I say minimal hit points -5. In this case, hibernate validator started validate the constraints and so on, and we know that minimal hit points should be positive or 0. We have -5, so we get a message: hello, this monster's minimal hit points must be greater or equal to 0. Right? And if you look at the log, where we have this is my response, right? This monster's minimal hit point must be greater or equal to 0. But if you look at the message, you can see that it's info, and it's executed of the event loop. That's reactive stuff I was talking about. We can also use, or try to use, rules again. I have a question here. Right. The question is, or the prompt is, give me a list of fantasy monsters with more than 50 hit points. Show me the result as an SPI table. So hopefully, okay, this basically means that we are calling our tool, and these are the monsters from my database that have more than 50 hit points. Cool, work. So in this example, we showed the hibernate validator integration and also reactive stuff that works out of the box for you.
Try to call it with negative number.
That's a good question. It could be actually shown. What about -5 hit points? I did not try this. Huh? We get this is the error message. I cannot search for monsters with negative hit points. The answer requires the minimum hit point value to be greater or equal to 0. So it's quite meaningful, I think. Okay.
What does the error code mean? Does it come from hibernate validator?
No. This one is coming from JSON RPC. It means something like, I don't know. They have just a few error codes, and it means internal error, invalid message or something like that. But it's listed in JSON RPC, the error codes. And it's basically, it's mandated by the spec that you should return something like that. Okay. So testing, that's another interesting area, because as I said before, with streamable HTTP it gets really complex, especially when you need to test some more advanced use cases with client features and stuff like that. So we started, first we started to use, like in the first version of the transport, we just used rest assured to send HTTP messages to the server, and then we, I don't know, Vertex client for SSE, I don't know, something like that. But then streamable HTTP appeared, and we realized that it's really difficult for users to test this properly. So we actually created something with original name called MCP-Assure. It's our own API. It supports all the transports that we have there. Streamable, legacy, and WebSocket. It's basically a fluent API that allows you to actually a little better. You create a client, in this case MCP-Assure new connected streamable HTTP client. In the background we we do all the discovery for you so that you know where to connect, which address to use, and so on. And then it looks like this. We say we want to test a tool scroll. This is the name of the tool. The answer. We pass some arguments, and then we receive a result, and we can use usual assertions to assert the result message. And you can group these calls. You can create a group of these calls, or prompt, how do you call it? Prompt gets and resources read, and then assert them. And when this one of these assertions from the group fails, everything fails, and you have to start from the beginning. So yeah, I wanted to show you a real test again. So in the test of our testing application, we have two tests. One is testing the answer tool, and this one is testing the list monsters. It looks very similar. In the beginning, we just say create a client for me, and then we say we want to test the tool scroll, in this case list monsters, where we say minimal hit points is 50, and the tool response should contain monster called Chimera. That's our test. And it's a classical quarkus test. So like you are used to write your test. So the only thing you have to use is this MCP-Assure API. Quarkus test as usual. You can use transactions, whatever, injection, all that works. Okay. So important thing, testing, especially when you need to test different transports.
Before we move on, if I would like to test basically a set of prompts to verify that if this prompt is sent, that the tool is actually involved, can I do that?
Well, not actually a prompt, because MCP-Server doesn't know anything about prompts.
With some LLM, of course, like.
Then you would have to somehow emulate the client, obviously, because in this case we only have the server. We don't have the client at all, right? In this case, our client is some mock thingy that behaves like a typical MCP client. So no, this API doesn't know anything about the model. You can't use like prompt like we used in Goose, like give me all the monsters, blah blah blah. No, you have to.
Should ask the same question, but yeah.
You could just use my MCP client for my check.js.
Yeah, I see what I mean.
Yeah.
Full-fledged MCP client that allows you to do this.
Exactly, or you could use any other MCP client that exists out there, but it's up to you. This is purely to test the API of the MCP server. So you're testing tool calls, prompt templates, resources, or resource templates. You're not testing the actual behavior. Like I said, you need the model that actually says, I want to call your tool in this example. And if you don't have the MCP client or the model, you can't do this. In the beginning, I was talking about the case where your application wants to use a tool that is using, for example, sampling. But a client actually doesn't have to support sampling. So we have a few APIs that help you with this kind of stuff. So something like we called initial check, where you can basically when the negotiation happens during the initialization, when the client does not support sampling, you can just quit the session or connection and say, okay, sorry, my requirement is that you need to support sampling. So this is we have a few APIs that allow you to do this, because otherwise it will blow up the runtime. Or you would have to check this in a specific tool. This initial check happens during the initialization phase. Yeah, sampling. Again, sampling. So I wanted to show you this advanced feature because I find it quite interesting. Unfortunately, not many clients support it. So Goose, for example, doesn't support it. I cannot show you with Goose. MCP Inspector does support that, so I will show you with the MCP Inspector. This is how it works. You have a tool. The description is returns a random fantasy monster with description. But in our database, I don't have a description of a monster. In my database, I have a monster which is an entity that has a name, level, and some hit points, right? So, in this case, I want to use sampling. I want to use the model that stands behind the client. And I want to ask the model to give me the description of this monster, to generate something, right? So what does it mean? Well, inside my tool, here in my code, you can run this code locally. I'm doing a check because not every client supports sampling, and if the sampling is supported, I'm saying list all the entities of the monster, select a random one, pseudo-random, and then for this monster, I'm creating a sampling request that is sent back to the client. There is a human in the loop that says, okay, I want to use the model for this request, and when I get the response back from the client, I create my final response, which is monster and description, which is monster and description attribute. Right? So this basically means that a client sends a request to our server to say, okay, we can handle this, but please ask the model that you have to give me some information. Basically, I'm sending a prompt, which again becomes part of the context menu. And we get some reply, and then we can include or, I don't know, decide what to do with the response. So in this case, I'm not going to use Goose because it doesn't support sampling, but I'm going to use MCP Inspector again. So connect list. Our tool is called random monster, right? Returns a random fantasy monster with description. So what happens when I click this tool and run this tool is that I get some notification here, which is sampling request or something like that. And I can basically mock the answer so that I can say it is large, maybe. Approve. So when I said approve, that basically meant that I'm sending the response back from the model, which is marked, and my tool can finish its processing. So if I look at the tool call, at the answer here, is it visible? Make it bigger. Right? So you can see that this is the response. And it says monster is ID 1, name Chimera, level 5, hit points 5, 55, and the description is the one that we gave from the sampling request. Make sense?
No. Is this actually useful?
Yeah.
Might be, why not?
Why not? Because I would expect the client to generate the descriptions if the user needs them.
Well, the thing is that then the client would have to know the business logic that is on the server. But in this case, we are just requesting some data and then processing it again on the server.
Or would I implement such a tool that needs to generate something when the client could generate it?
Well, it could generate something, and you can, for example, decide which business logic to execute based on the result. I'm not saying that it's very useful.
I'm not surprised that the clients do not support this.
Well, there are few that do support it. MCP. One of my colleagues tried to implement a lot of stuff with MCP, and he told me like 2 months ago that it's good, it sometimes work, but it's like Wild West. Like, you never know actually. Yeah, there was a question.
I think this, if you don't need it in MCP, it's perhaps you could describe it in the tool that you need this info if you are sure you know it.
Yes,
But
of
maybe
course.
the use case could be if you start chaining LLMs, then inside the MCP there will be another LLM. And then the LLM needs something, and then it needs to drill to the client.
Yeah, might be. But then it gets complicated, and to be honest, MCP itself is not very well designed for this kind of stuff, because our guys from Quarkus, they're working on various agentic communication stuff that is completely different. Like the primary purpose of MCP is just serve one or more AI agents. It's not like connecting multiple AI agents or stuff like that.
But I still don't understand how this would work if I would have like normal client with a normal LLM. Then basically if the MCP server decides that it needs more data, LLM should query back to the client.
It doesn't have to be the data. It can be whatever. You can just, leverage the model for basically send a prompt to it, and then pass the response and decide what to do then next.
So either LLM can generate that additional stuff, or it can even like reprompt back the user in the response, like I need this following information before.
Yeah, of course you can do like several tools, and they are somehow like say this tool can be used first and the second and so on. But in this case we have one tool invocation, and then we just request information from the user. Basically, sampling is one of the features. The other one they introduced in the last specification, I believe, is called elicitation. Cool names, right? And elicitation is something similar, except it doesn't ask the model, but it asks the user. So basically, if you, for example, if you have a code UI jet application or some development tool, when the server needs some information from you, it just pops up like the MCP server requires your name or whatever. You pass the information and it goes back. It's a very similar approach, except that in sampling we ask the model, and in elicitation you ask the user actually. So it's very similar. Yeah.
I'm wondering about the security of that. If, as a user, I have my model, I have my UI, but I'm using MCP server, which is belong to online shop, for example, and I want to try something about there, but then online shop cannot request something to the model, and the model might have information about me that I want to share.
Yeah.
There is some,
So security is a completely separate chapter. In the first version they didn't care about security at all. Then they tried to improve it. In some cases, like obviously for HTTP, you can use some security stuff on HTTP, and it works out of the box. Like in Quarkus, when you have Quarkus security present, then you can use all of the stuff that is there, like annotations and configuration and stuff. Obviously APIs and so on. But for this sampling, for example, there is a requirement that the server cannot send a request to the model without confirmation from the user. Never. That's a requirement. But obviously, it depends whether the MCP client implements this correctly.
Maybe the correct question is how many of the thousands of MCP servers are written in JavaScript?
Yeah. Actually, last month I read a small comment that was about MCP during the last year, because it's relatively new. Thousands of servers were created, but I wonder how many actual users of these MCP servers exist, because everyone wants to implement MCP server because then you will have all these cool features provided through MCP, but it has a lot of limitations. For example, as I talked about the context window, right? You cannot just connect your client to thousands of MCP servers because you can blow up. So it's really, everyone is now implementing MCP servers, but the usage, I don't know. Yeah, this is my last example, again, of something that is slightly a bit complex, which means that streamable HTTP is here in this case, and it's Progress API. So imagine that you have a tool, for example, that takes a long time, right? Something that you have to do, compute something really large data set, whatever. And in this case, MCP defines something that is called progress notifications, so that you can send back to the client information about the progress. 5%, 50%, 80%, stuff like that. And again, in this case, it's slightly bit complicated because we have to, in one invocation of our MCP feature, we have to send many responses to the client. So it gets a little bit complicated, but we have some API for that. I will not go through this. If you want to take a look at the example, and you can even try it. Here, again, with MCP inspector, it works just fine. I can actually run it. It's the long running one. So I'm going to run the tool. As you can see, we get notification about the progress, and then it's complete. So in this case, we have a nice API for this. You can do this, but again, if you want to test it without our API, it gets a little bit complex because you get many responses from the server, and it's not like simple HTTP request and HTTP response back. I think that's all. So thank you. If you have any questions, raise your hand. Now is the time.
I have one question. Actually, write it down. So basically, you mentioned that you can basically send the response from the MCP in different formats, in text, in JSON, and so on. Have you experimented, or do you know, for example, the best way how to present data to the LM tool? For example, in JSON, it can be, for example, confusing for some more dumb models, but in I don't know, Markdown it can be better. Have you tried it? Do you have experimented with it?
No, in my case, well, I only use Gemini for testing usually, and JSON is just fine. Like, it's not a problem. But yeah, you are correct that actually what you return back in our examples, you always use text content, but MCP actually defines more types of content. Like you can return binary content, which is basically a long base 64, text, and you can return, I don't know, images and stuff like that. But JSON always works just fine for me, at least. But I'm no big user of it. So.
The security, I have to admit, that was the main reason I was actually going, because I was wondering how the security will work. And does it mean that the quarkus-server will provide the security layer it already has? And
so it depends.
Security is topic for a client mostly.
So it depends on the transport, obviously, because if you use standard input-output, then there is no security involved because you have sub-process started, and we just use standard input-output, so there is no security considered. If you use HTTP, transport, and under the hood there is the classic HTTP server, I mean from Quarkus. So we basically use, when Quarkus security is involved, and use everything in the same way. So there is, you can use all out, you can use form based out, whatever, and yeah, you can even in your tools you can inject security identity. You can use annotations like rows allowed and stuff like that. But everything works out of the box because we are standing on top of the default HTTP server from Quarkus. We basically add a thin layer that it's a proxy that calls your tools and prompts and resources methods. But under the hood there is actually a vertex handler, and all the stuff that is provided by Quarkus is there. So we didn't do any special thing in this area. By the way, there is a nice blog post from Sergey, our colleague, that is our security specialist, and he wrote a blog post about using MCP-server suite and security. If you look at quarkus.io, yeah, I can show it. Community blog, and I believe that it's in the security. Yeah, that's this one. So very nice blog post. So if you are interested in security and MCP, we actually added one feature because Sergey requested it, and that's that when you use an HTTP transport, you can define multiple configurations of your MCP server, so that you can use, for example, different path providers. Yeah, you can basically normally when you start your application, you have one URL where the MCP endpoint is exposed, but you can actually have multiple of them, each one with different configuration, with different security configuration and stuff like that. That's also possible.
So this is fully transparent through the LLM actually, so you are never providing the token to the LLM.
No.
Right.
No, to client, the MCP client.
Yeah, the MCP client
no,
don't like directly handle everything on their side. I have one more question, but it's again more about the client. Shouldn't it be possible, because you usually don't control the MCP server, that's kind of the point, you want to reuse somebody else who is providing the tools, to specify that I'm not interested in all the tools that the server provides, so my context window is smaller?
This is actually a very good question, because we have this feature request since the beginning, because obviously you write one server and you want to probably provide different tools for different users. So on the client side, you have to filter the tools like your way. It's up to you. On the server side, we have in our MCP server implementation, we have a notion of filters where you can basically, based on some information from the client, like name of the client, version of the client, client features, and so on, you can filter the features or like tools, prompts, resources as well. But it's the good question. It's a good question because the spec doesn't care about it at all, which is unfortunate.
If you use Claude, for example, then you can toggle individual MCP
Yeah,
servers
that's the-
and also the tools.
But that's the client part, as I said. Claude just takes all the tools from the server, and then you can say, I don't want to use this and this and that. But it's up to the client to decide, right? So it's
So I kind of expect that the server doesn't expose the tools
Doesn't-
the client or the user is not authorized to use.
no, the server actually doesn't care about this. It just returns all the tools it has.
Okay.
And then it's up to the client to decide which tools are actually for which the user is authorized. But as I said, we have a feature that allows you to filter somehow the tools, but it's not. The problem is that it's not defined in the spec. Like because we want to be transport agnostic. You cannot use like HTTP thingy, like I don't know, query parameters, whatever. Because we only want to use the messages, right? So there is actually something they call metadata that allows you to provide some metadata, but it's implementation specific. It's not standardized.
So currently there is no way to specify some authorization levels. For example, you need to have your token because there is some token and it has some information in it. So we have to have, for example, an admin authorization level to actually access this tool, or can you?
Well, you can use, like I said, you can use existing stuff from Quarkus security, for example, but then it's transport specific because it only works obviously for HTTP, for example. Well, it actually works even for WebSockets because we have somehow implemented it, but it's not like, it's not like using you cannot specify this directly in the message that is sent from the client to the server. Well, you can use this metadata, but it's undefined. The content is undefined. Yeah.
So with HTTP-based transports, I imagine that the client sends the user's token, forwards the token of the user with each tool call. So
Yeah.
each tool call can belong to a different user with a different token, right? How would this work, if it does work, with WebSockets? Because with an HTTP you can forward the authentication token with each HTTP request, but with a WebSocket, once you start a session, how do you pass a separate token for each user?
Yeah.
One
So
session might be used by multiple
in
users,
WebSocket,
right?
in WebSocket we actually stand on the shoulders of WebSocket Next, where the security is solved in a way that when you connect to a WebSocket server, then you have to be, basically the token has to be available, and then we create a session, and this token is used for the whole session.
So only
For
one token. You can't have a separate token for each tool.
Well, you have, yeah, you're right. You can't do it's per session, basically, per the connection or session, whatever you call it. You can't have different tokens for different requests. But it's like, this is how WebSockets work. Like
Right, but you could theoretically somehow pass the token inside the WebSocket messages somehow, right?
well, yeah, you can.
If you wanted this functionality where each user of the application gets different permissions. And
Yes. And in theory, if you want to, you can just make it part of the message. Because it's up to you, but that's, yeah.
But it's not implemented like that right now.
No. And even our WebSocket implementation doesn't allow this.
You said the MCP server can decide to change the list of tools it provides to the client. Can you do that at any point, or is it only on client request?
Our API works the way that whenever a client calls to list, which is give me all the list or give me the list of all tools, or when a tool is called, we apply the filter. And if it matches the filter, if it's allowed, then we include the tool in the list or respond to the call. And if it doesn't, then it's not included in the list or the call fails. Do you understand? I'll show you an example. Here. Maybe it would be worth to show you that we have nice documentation, long documentation, and there is okay, this is part, it's not big enough, right? Oh, where is it? So it looks like this. You just implement a CDI bean again because we are CDI based. You implement a special interface. It's called tool filter or prompt filter, whatever you want to filter. This is how it looks for a tool. You get a tool info which includes the name, description, arguments, and so on. And you also get the MCP connection that represents the user session, basically. So you can see the client name, you can see the client version, client capabilities, or whatever. And then it's up to you to decide. If you return true, then this tool will be included in all, basically in all communication in this session. If it will false, then it's completely ignored. Meaning that if you, if the client asks for all the tools, you will not see your tool. And even if he tries to call the tool, like, I don't know, for whatever reason, it fails. Because you say, okay, no, it doesn't pass the filter. So, fail.
Sorry, if you want to continue, I thought that you finished.
No, that's all.
So, you left open one thing which I think is kind of important. Why Quarkus does have its own API for MCP server if there is like de facto standard SDK in Anthropic?
Yeah. Well, first of all, when we created our API, our MCP extension, then at that time no SDK existed. That's the first thing. And it didn't exist for a long time. Then it's a bit unfortunate that we kind of tried to contribute our, at least the declarative API, so that is unified. But it didn't work for some reason. And the actual SDK was actually, in the beginning at least, contributed by Spring. And it's only about creating, using Programmatic API to create the servers and send messages and so on. So it actually doesn't fit our use case at all. Because we first of all wanted declarative first, because that's how we do it usually in Quarkus. Optionally with Programmatic API. We wanted to use all the stuff that, that we actually have in Quarkus. And this SDK that is available is not needed at all for us, or from our point of view. So right now it's a bit unfortunate situation.
That's not everything. They actually also included Spring classes in the official SDK, so we cannot...
It was just a variant. They also included this reactor thingy. You know, in Quarkus we have our own, we have Mutiny, and they have different, it's complicated.
Yeah, so we cannot really implement it because otherwise we would need to pull Spring APIs into Quarkus.
Yes, more or less. And even if we implement it, we don't get anything, even the users, because we want users to use, you know, the API I showed you. H2O method works, Mutiny, blocking, non-blocking. But this SDK is basically about creating the servers, like using some Fluent API and providing some lambdas and stuff like that, which is not interesting for us. Actually, there's this MCP thingy is 1 year old, right? Which is quite new. The other thing is that in AI world, 1 year is like ages. But Anthropic, since the beginning, tried to drive this standardization process, but they kind of didn't care about other vendors and stuff like that. So, funny story, for example, when I started to implement the first version, I included links to the specification in Java, because I thought, okay, this would be nice. You click on the link and you get the information from the spec. What happened? In the next version, they broke all these links. They created new links for the next version. Your links didn't work. So I said, okay, I'll just update. They probably just changed their mind and so on. In the next version, they broke it again. So I removed all the links from the Java because it doesn't work. And this approach can be seen in many areas here. So it's a little bit, yeah, unfortunate. So that's why I said that from my point of view, it's a very big problem that there is no foundation that would be vendor agnostic, independent, you know, so that others can collaborate. It's just Anthropic's show.
Have they considered moving to the foundation, or have they declined it?
As far as I know, they did not want to. contributed to the foundation. But things can change because, as I said, they're trying to improve things, which is good news. Like I said previously, that the development and review process actually have a link there. It was quite funny because when we wanted to contribute to the spec, their what is it? So this is still active contributing document, and it was like this. This was the contribution process, like here you go. You create fork, you send pull request, you wait. That was it, right? The good thing is that they really improved. They created a very complex contributor communication page. They call it SEP, something like standard. I don't know what does it mean. It's really complex, and again, it's their specific stuff. So the good news is that it exists, and you can somehow try to contribute in a reasonable way, but it's not like CNCF or Eclipse Foundation or something like standardized processes or anything like that. It's still, but like I said, it's really evolving. And for example, this, you can see what priority, you can see the roadmap. And compliance test suites, that's the TCK part I was talking about. So they have it on the roadmap, and hopefully stuff or things will get better. They even think about reference implementations, which is interesting. These things are important because when the spec is not good enough, which any spec, no spec can cover 100% of use cases, right? So it's good to have something like compliance test suites, TCKs, reference implementations, because they basically serve as another source of truth. So that if you say, okay, this looks weird in the spec, you can take a look at the test and the reference implementation, and then you see how it was actually intended, right? So all these things, if they do that in the future, it will be great, from my point of view at least. So,
does MCP work with all the models?
it's MCP doesn't care about models. It's up to the MCP clients to implement the communication with the models, right?
And when the client receives the list of tools from this server, it has to forward back to the model.
Yeah, obviously the model has to know how to call the tools, for example, which not all models know. Yeah, but I don't think that all models support it, right? Yeah.
To call this something that is specified somewhere?
Tools are exactly the same thing, just inside the same application as the client.
Yeah, you ever use LangChain4j, you can have tools in your application, which is basically the same like these tools, except that we externalize the tools to some reusable server. So it's basically the same principle, except you don't have a tight coupling with inside your application, and you can just connect to a server or reuse the server and stuff like that instead of having these tools inside your application. But it behaves in the same way.
Okay, let's park it and let's continue the discussion over some beer.
Okay.
Thank you.
Thank you.